This section is going to be on proving lines parallel. This is section 3-3 in your textbook. The essential question for this section is, what are different ways in which two lines can be proved to be parallel? In the previous section, you learned that when two lines are parallel and they are cut by a transversal, certain angles are formed and there is certain facts that you can deduce about these angles in terms of them being either congruent or supplementary. We're going to reverse the situation here in that we're going to take and know something about the angles and see if we can prove that the lines are parallel. Now, to begin with, I'm going to repeat postulate 10 so that you can see the wording and then compare it with postulate 11. So postulate 10 simply states, if two parallel lines are cut by a transversal, then corresponding angles are congruent. Now postulate 11, which is introduced in this section, states, if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. Now if you look at these two postulates, postulate 10 and postulate 11, you can see very easily that these are converses of each other. In the first case, you're saying you've got parallel lines, then the corresponding angles are congruent. The second is saying if you've got corresponding angles congruent, then the lines are parallel. Now let's look at Theorem 3-5. This is the first theorem of this section. And it states, if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. Now, you can look at this and realize that this is simply the converse of Theorem 3-2. So if you know 3-2, you make the converse and you get Theorem 3-5. Theorem 3-6 says, if two lines are cut by a transversal and same-side interior angles are supplementary, then the lines are parallel. And this is simply the converse of Theorem 3-3 from the previous section. Next, we have Theorem 3-7, and this theorem states, in a plane, two lines perpendicular to the same line are parallel. And this relates back to Theorem 3-4, which said if you have a transversal that's perpendicular to one of two parallel lines, it's perpendicular to the other one also. Okay, now we will have three additional theorems which involve parallel lines, and in one case, perpendicular lines. And we're going to present them now. Theorem 3-8 states, through a point outside a line, there's exactly one line parallel to the given line. Now, if you think of a line and a point not on that line, what this theorem is saying is that you can draw only one line through that point that's parallel to the given line, okay? So, through a point not on the line, you can draw only one line parallel to that given line. Now, Theorem 3-9 is related to Theorem 3-8, except now we're talking about perpendiculars. So, Theorem 3-9 states, through a point outside a line, there's exactly one line perpendicular to the given line. Again, what are we saying? We're saying we have a line, and we have a point not on that line. Through that point, we can draw one and only one line perpendicular to the given line. Okay? So 3-8 says you can only draw one line parallel to the given line to that point. Theorem 3-9 says you can draw only one line perpendicular to the given line through that point. Finally, we have Theorem 3-10. This theorem states, if you've got two lines, each of which is parallel to a third line, then these two lines are parallel to each other. So two lines parallel to a third line are parallel to each other. Now I would like you to list all the different ways that you can prove that lines are parallel and post this list in the Dropbox. Thank you.